Just wanted to make a follow-up video for you because it'll be a little bit easier for me to explain this way. So if you're looking at your 2.2 lab, what we want to understand is how do we use the information from the data table and plug it into these equations. Okay, so now I think I had 15.6 degrees here yesterday. I might have said this was 30 and this was 100, but let's adjust them like this just so our numbers kind of work out. So basically, the first thing that we need to do is analysis question 1 says that we need to solve for the heat that was added to the water. Okay, and so if we look at this, we know we need to know the mass of the water, or change in temperature of the water, and then the specific heat. And we remember the specific heat of water is always 1. Okay. So let's start looking at our data table and figuring out what we need to plug in here. Okay. So we know mass of the water is 40 grams. Okay. So we can just plug that into there. Okay. So 40 grams. And then we need to figure out the change in temperature of the water. So if we took 31 minus 15.6, we should get a change in temperature of 15.4 degrees Celsius. Okay. And again, we know the specific heat of our water is 1. Okay. Now, this will allow us to find how much energy was added to the water, because we know if we add energy to something, the temperature goes up. That's why we saw our temperature rise from 15.6 to 31. Okay. So now, if we do the math on that, my calculator, go. So I take 15.4 times 40 times 1 equals 616. Okay, so 616 calories. Now, why that's important, what we're doing in this lab is we want to remember energy isn't created or destroyed, it's transferred. Okay, and when we talk about heat, we're talking about energy. So 616 calories worth of energy were transferred into the water. That's what caused this temperature change. Okay. So now, where did that energy come from? Okay. That energy came from our piece of metal. Okay. It had high energy. It's going to transfer that energy into the water. Okay. So now, what that means is we can plug this number in for H over here with our metal. Okay. So now we just simply say, okay, well, if we know that the water gained 616 calories worth of energy, that must mean our metal lost, right? Negative, lost 616 calories worth of energy. Okay. Now, then we just simply do the same thing. Okay. So we know the mass of our metal was 40 grams. Okay. And then we're going to look at our change in temperature. So I started at 100 degrees Celsius, 101 degrees Celsius, and I dropped down to 31 degrees Celsius. Okay, so that's a change of losing or negative 70 degrees. Okay, and we don't know specific heat, but that's what question 2 is asking us. It says solve for the specific heat of the metal. The key piece was we had to figure out how much heat went into the water, and that amount of heat or energy was transferred by the metal. That's how this works. Okay, so when we do the math on this, let's see, 40 times negative 70 gives us negative 2,800, right? Times CP. Okay. Now, this is the one tricky part. Okay, just like in math class, we have multiplication here. So that means we undo multiplication, so with division, so we divide both sides by 2,800. Okay, negative 2,800. Okay, and that's going to give us our value for specific heat. Okay, so when I do negative 616 divided by negative 2,800, I get a specific heat value of 0.22 calories per gram degree Celsius. Okay, so hopefully that helped. The big piece here is just understanding what we want to learn from this lab is the reason why the water heated up by this much is because energy was added to it. Right? We had to add energy into that water to make it change temperature. Where did that energy come from? It came from the hot piece of metal that we dropped into our water. Okay. So now with the last part, it says, okay, use the data table to identify which metal we had. Okay. So you're going to use your data table and then answer those synthesis questions the best that you can. Okay. Hopefully this helps. See you soon.